Namaste. Hello, everyone. Hello, Professor Azim.
Namaste, namaste. How are you?
I'm good. And I would like to wish you all a very happy Diwali.
Yeah, same to you. Okay, so since you have joined, so then let us start the program. Uh, Let me introduce you that yes, our next speaker is Mr. Pratik Singh Thakuri from Nepal, and he is the research and project officer in Center for Research and Environment, Energy and Water, and he has been working on a logical model. And I thought that why not learn the experience of a person working in Nepal and how they people are doing uh, in the area of ecological model and how they are managing the data and all those things. That what is the data limitation, and so that keeping this in view, I thought that let us invite Mr. Pratik Singh and that listen his that experiences. So now the stage is yours, sir. You can start your presentation.
Yeah, thank you, Professor Azay. Let me give more some of my information and my
Yeah,
introduction,
please.
elaborated one.
Yeah,
So
yeah.
I have recently joined in the academic field as an assistant professor in Nepal Engineering College. Yeah, so I'm also in your club as a teacher or as a professor. Yeah, and uh, talking about Nepalese context of hydrological modeling, data management is quite similar to other South Asian countries. But the thing is, in Nepal, the department of which take cares of all these hydrological and meteorological data are single data. I think in India and Sri Lanka and other countries, they have meteorological department, and the hydrological data are taken care by other governmental institution. But in Nepal, it's a department of hydrology and meteorology. They're integrated. Yeah. So I'll now go to my presentation. Is it visible now? My screen.
Yes. You are clearly audible and your screen is visible. Now you can go to slideshow.
Yeah. Yeah, thank you. So the topic given to me, or I've chosen the topic, was hydrological model as a tool for water resources management. So for this lecture on faculty development program on modeling of water resources system, uh, and it's a great honor, and I would take it as a privilege and thank Professor Azay for giving me this chance to deliver a lecture in his esteemed institution. So my name is Pratik Singh Thakuri, and I have master in engineering in water resources engineering from UNESCO Madanjit Singh Center for South Asia Water Management, University of Moratuwa, Sri Lanka, and I have completed my bachelor in technology from Kathmandu University as an environmental engineer. I'm currently associated with Nepal Engineering College Center for Postgraduate Studies as assistant professor. So today I'll be, touching a few topics regarding hydrological models and how it should be selected, and what are the important things to be considered while selecting models, and then other things to be considered for a holistic and comprehensive hydrological modeling. What are the things should be considered? Yeah, I'll be touching all these areas, not so much in detail, but yeah. I'll give a quick overview and share some of the literatures I have found interesting, and I'll be sharing the references as well. Yeah, so I'll be talking about hydrological model and how hydrological models should be selected, and what are the criteria for model selection, what are the objective function, what is the importance of objective function in hydrological modeling. And the fifth thing I have included here is the flow duration curve for model calibration and validation. Why it is important, I'll be talking about that as well. And if you have time, I'll briefly share my spreadsheet of flow duration curve and how it can be utilized for model calibration and validation. Yeah. So yeah, I think Professor Ajay has touched all this topic in his initial a presentation. I was also listening as a participant in that presentation. So he have touched basically all these hydrological model theoretical concept and the principles and everything. So I'll not dwell more in these areas. Yeah, but let me briefly summarize what is hydrological model and how hydrological model, what are their types and everything. So hydrological model or model itself is a simplified representation of real world. It's a simplified representation of the real world. So no model is perfect in itself. It's just a representation of the real world. And what is hydrological model? So hydrological model describes non-linear and dynamic transformation of precipitation or other the meteorological condition to runoff through the process of such as surface and surface flow, infiltration, interception, evaporation, transpiration, snow melt, and so on. So hydrological model, or they also say a rainfall runoff model. So how the precipitation, either it is in the form of rainfall or a snow melt or something, so how it is converted to a runoff. And there includes a lot of other processes, hydrological processes, in either it be overland flow or surface flow or infiltration, evaporation, transpiration, snow melt, and etc. So including all these processes and converting precipitation to runoff is mainly what hydrological model does. So it comprises of a set of equations to estimate runoff, and those equations are the function of various parameters used to express the watershed characteristics such as geography, geology, land use. So the equation of hydrological models are basically the function of the multiple parameters describing the watershed characteristics. Either it be the geological condition, a geographical condition, their slope, their land use, their soil type, or their infiltration capacity due to their the peculiar soil type, or anything. The specification or speciality of the watershed are exhibited in the function, and those parameters, as a function of those parameters, those equations and those set of equations as a whole works as a hydrological model. So there comes a question. There are a lot of hydrological model existing in till date, but what is the the best hydrological model? So the best hydrological model, as per the definition, there is nothing such called a best hydrological model, but the model which gives a result close to reality and use least parameter and model complexity is the best hydrological model. So there are a lot of types of hydrological model. I think Professor Ajay has already touched this area, but I'll briefly go into it as well, because it will be a warm-up session in the beginning before entering into the depth. Yeah. So hydrological model can be classified into a number of types, but I have listed here 4 types of hydrological model based on representation, process representation, spatial representation, time representation, and the aspect of randomness. So on the basis of process, it can be physical, empirical, or the conceptual. So I think I need not go into the definition of all these types of models. Yeah. So based on spatial representation, it can be semi-distributed, lumped, or distributed. And based on time representation, it can be static or dynamic. And based on aspect of randomness, it can be stochastic and deterministic. So yeah, there are different types of hydrological model, and they can be classified into a number of types. So the question arises here: what is the best hydrological model for implementing in your watershed or your river basin? What would be the best hydrological model? So there are a lot of types of hydrological model. They can be classified into numerous types, but when we use a hydrological model, which would be the best one to be used? So it's just like it's not just like a video game gimmick. You choose, there are a lot of speciality and specs, and you choose the speciality from all this. But you have to in a scientific research or in an engineering process, your selection process should be rational, or you should have a specific description or your justification why the model was selected for the study, the research. So I'll be talking about how to rationalize the selection of model for your research study.
Hello, sir.
Yeah.
Sir, sorry to disturb you, sir. Your slide is not moving. Just in fast slide.
Is it just a fast slide?
Yes, sir.
Is it now visible?
Yes, sir. Now visible. Yes.
Okay. So in the from the beginning. Is it now visible? The types of hydrological model, I'm showing it in the screen.
Yes, sir.
Okay. Yeah. The selection of hydrological model. Yeah. So I was talking about it should be rational and justification should be done. So it's not a process of the train that if someone else has used a hydrological model, that would be a best hydrological model for your watershed, or for a researcher to conduct a research study. There are a lot of factors to be considered, a lot of criteria to be taken under consideration for hydrological model selection. So it's a crucial and subjective process. It's not a very objective, but it's quite crucial and subjective process of selection of hydrological model. And as I have already told, that no model can be identified as an ideal for all range of hydrological condition and watershed characteristics. So if a hydrological model was performing really good in the tropical condition, it may not be very good for an arid condition, or it may not be very, it may be completely obsolete when it is trying to be used in the higher Himalayan river basin, where the snowmelt contribution in the watershed is predominant. Yeah. So for there is no model that can be identified ideal for all hydrological condition and watershed characteristics. So so while selecting hydrological model, it should not be supposed to be solely reliant on predictive performance. If you get a hydrological model which gives you best performance in terms of your hydrograph simulation and in the hydrograph matching and all these objective function and efficiency criteria, it is showing really good, but that is not what you should be solely reliant on. There are a lot of other factors that should be considered. So the first thing would be the model preferences, modular preferences, or familiarity toward the model. So that should be also be considered as one of the criteria for selecting the model. If the modeler is not very familiar to that hydrological model, the output of the model, even if it is really performing good in other watershed or other study, it may not give the result good in that case. Yeah. So another thing is the aim of modeling task. Third thing is time availability to develop and apply the model. And the fourth is the level of accuracy needed. So aim of the modeling task. So if the model is aimed for for agricultural water management, or the water resources management, or the drought management cases, in some very the area where the river has mostly low flows conditions, or it's as a seasonal river or something like that. So then the aim of modeling would be different than if than the like a flood management or disaster management cases. Similarly, what is the time available for modeler to develop the model and apply the model? That would be also a very crucial thing to be considered. If you are going through a rapid assessment of a watershed, you need there has been a flood, and you are given an assignment to assess the condition of the watershed and everything with the hydrological model. You are not going to perform a modeling which takes a really big time and effort and such kind of thing. You rather go for a model which gives a quick outlook of the watershed, or some picture of the watershed. If you can depict some picture of watershed and you can get some ideas from the model, that would be fine. So the third thing is the level of accuracy needed. Like I have said, like in some research, you really try for a better result in the your study. But in some studies, just like I have mentioned before, in the rapid case study uh, or anything like you are performing. Um, so you may not need the higher accuracy uh, of the model. So in that cases, the preferences of or the selection of model can be different. So the basis of the selection of model, as I have already told, maybe very, different as per many criteria. So I have listed some basis of selection of model, like purpose of the study, nature of the watershed. If either it's a rural watershed or the urban watershed, the selection of model will be different. What is the data available in your watershed? If there is very less data available and you are trying to use a model like SWOT or something like other model that requires heavy amount of data, then the model would be considered as inappropriate. And something and another basis would be adequate knowledge on model parameters. If the model developer claims his model is the very good performing model, but the parameters are not already estimated in other watershed, validated on other watershed. In such cases, the modeler, the initiator would face a lot of difficulty on estimating parameters and everything, and it would be a huge task for a modeler to start things from scratch. And another thing is the knowledge of model processes and step. The modeler should have in-depth knowledge of the processes and step. Although else the model developer should have given the appropriate reference manual, user manual of the model. Otherwise, all the models have inline equations and inline theories and hypotheses and assumptions. So that should be considered. That would be a very important criteria to select the model. And the third thing is the complexity of model, and the last is the cost and availability of model. So all the models are not in the public domain in a free to use. There's models which are exclusive, and there are some models which are you need to pay for it. So if you are in the limited fund, or if you don't have any budget for your study in purchasing the hydrological model, so you rather go for the free domain model. The models available in free domain, whatever if it's a drawbacks, you will rather choose the model available in the free domain. So there are a lot of factors that should be considered while selecting the model. So yeah, I have talked in a broader spectrum of selection of model, but now I'll be pointing out it in the bullet form. So criteria for selecting hydrological model. Yeah, it is not limited to these 7 criteria, but you can suggest me, or you can when you are doing your study on your own, you can add other criteria for selecting models and other the evaluation of the framework. You can develop it on your own, but I'm just sharing my criteria on selecting the hydrological model. And I have also published a paper on selecting hydrological model on Journal of Water Engineering Management, where Professor Ajay is the chief editor. So I'll give the reference of my paper as well in this presentation. So there are I have listed 7 points, 7 criteria for selecting hydrology model. So the criteria number 1 is temporal scales. The criteria number 2, spatial scale. 3, hydrological processes. 4, documentation support, resource requirement, user interface, and model acquisition cost. There could be other criteria as well, but for my study, I have considered these 7 criteria. For me, model acquisition cost, if it is exclusive, and if you have to pay for it, even the model is performing really good in all these criteria, that would the model which is exclusive would get obsolete and get 0 value in my criteria evaluation, which I'll be talking later. So these were the my criteria. And
the slide is not moving, sir.
Hello.
The slide is not moving, sir.
So now it's moving. Is it visible now?
It is not moving, sir.
What is the problem? Now it's visible.
Yes, sir. Yes, sir.
Yeah. So I'll be sharing in the normal mode rather than presentation mode. I think the presentation mode, slide share mode, is having some problem in my computer. I don't know. So yeah, so for someone who have very less data, or working in the watershed with a data scarcity or data scarce environment, for them the data requirement and other things would be a special criteria for model selection. So likewise, you can list out your criteria for model selection as well. But yeah, I'll be talking about these 7 model selection criteria, and would expect you all to give feedback. What else could be the criteria for model selection? So temporal scale. So models are selected depending on the objective of model study. So for example, if if model is to be carried out for the estimation of hydrological flood, the design estimation of design flood or storm, then event bus model would be suitable to selected if you just want to design a culvert and or a storm event. So the event bus model will be suitable to for those purpose. But if you want a modeling to be carried out for the analysis of flood, drought or water resources, then the continuous model should be selected. So based on this temporal scale, the event based or continuous, the rationale of selection should be there, and the purpose of the study should be clear. Similarly, if the natural process of the watershed is expected to be detailedly elaborated in the model, then the model with shorter simulation time step should be chosen. Secondly, the spatial scale. If the model want to focus on spatial variability of meteorological factors, non-uniformity of the watershed characteristics, or the heterogeneity of the watershed characteristic, like topography, land use, vegetation, in detail, then distributed modeling is suitable one. Else the suitable modeling approach would be lumped. But if you really want to represent the spatial variability of the meteorological factors and the heterogeneity of the watershed conditions and everything, then the distributed model will be suitable. But the complexity of the model processor and the data requirement and everything would thoroughly increase if you go from lump to distributed. The distributed model is less complex compared to what the lump model is very less complex compared to distributed ones. So the complexity of model is another factor in the selection of model. So what is the complexity you would like to deal with? What is the level of data you have available? That would be another factor. So if you have very less amount of data, or you have very less amount of time and knowledge to deal with in the hydrological modeling, then it is not advisable to go to the distributed modeling. It is really it demands higher amount of data, and it use time. Even your computer specification requirement could go high. So similarly, the lump model is just assumes whole watershed as a single unit, whereas a distributed model disaggregates a watershed into a number of subunits, where semi-distributed models can operate in this sub-watershed scale. So there is a third model type that is called semi-distributed or pseudo-distributed model, where it is a compromise between lumped and distributed model. In the lump model, the model assumes whole watershed as a single unit. Whereas in the distributed model, the model disaggregates watershed into numbers of subunits. Whereas in the semi-distributed model, model are disaggregated in the smaller sub-watershed scale. So another avenue of the watershed modeling or hydrological modeling was semi-distributed model, and which is gaining quite popularity these days. Yeah. So advantage of distributed model over lump model is not better prediction of stream flow, not just the better prediction of stream flow, but also the ability to produce stream flow prediction in the interior location of the system where flow measurement are not available. So in the lump model, the stream flow are predicted at the outlet of the hydrological, the watershed. But in the distributed model, you can predict the hydrograph or the discharge flow in the interior of the watershed as well. So distributed model, as I've already said, that it is has more advantage and a lot of drawbacks or demerits as well. That can be a limitation due to the high cost associated with the input data. Similarly, the semi-distributed model, that can overcome the limitation of the both lump model and the distributed model, and can predict the stream flow at the defined sub-watershed unit, and with relatively very less amount of data and computation complexity than fully distributed model. So there are drawbacks of the lump model, and there are advantages of the distributed model, and both the drawbacks of the distributed model as well. So there is a compromise between lumped and distributed model, the semi-distributed model, overcome the limitation of both lumped and distributed model, and can predict the stream flow at the sub-watershed level, and demands comparatively less amount of data compared to the distributed model. So what is the purpose of your study? What amount of time you have, what amount of data you have, that would be very important while selecting the spatial scale, dealing with the spatial scale of the hydrological model. The third thing is the modeling processes. Either it is the physics-based model, conceptual model, or empirical model. Yeah, I'll go with the empirical to the physics-based model. So the empirical models are, they are used for rapid study and like a quick outlook, and if you have limited time and data, just like I have told about the lump model. If you have really limited data, and you are going for a rapid case study, you have limited time, then the purpose of this study, you will rather choose the empirical models, just like there are rational formula or something like unit hydrograph model. You just go for it and estimate the flow hydrograph of the watershed. But if you really demand high accuracy of the model, and if you really have a high availability of the data, and also have a deeper understanding of the model or hydrological processes, then the physics-based model would be the appropriate one. But it demands high data, and the modeler also should have a very deeper understanding of the hydrological processes. Whereas the conceptual model has a fair accuracy and limited, and the amount of data is also comparatively less. The data demand is also comparatively less compared to the physics-based model. So like semi-distributed model, that the conceptual model overcome the drawbacks of empirical model and the physics-based model as well. But as I've already told, that there are the models are selected based on the modeler's requirement, their purpose of the modeling. So that is the important factor. What and where you should go, and how should you choose the model. So looking at the modeling criteria, you should go if you have deeper understanding of the watershed processes and high amount of data, then the physics-based model would be really good. Else, if you are going for a rapid case study, you just go for the empirical model. So you cannot say that this model is the best and ideal or perfect model. So And the real scenario is quite different. Physics-based model are generally selected over conceptual model, but parameters of physics-based model needs value from real observation data, and the values of real observation model have if the values of physics-based model have to be estimated or guessed due to lack of ability of field measurement, then the result is not likely to be reliable than the result obtained from the simple conceptual model. So the physics-based model often require the data from the from the real observation data, and if in the absence of real observation data, if you guess or estimate those data and enter it in the model, then the result are likely to be less reliable than the result obtained from the conceptual model. So so conceptual model so in the absence of real observation data, you should not go for the physics-based model. Is it audible? Yeah. So
Yes, sir.
yeah. So third, another component in the model processes would be flow routing. The flow routing processes available in the model. So flow routing option available in the model is another important component to be considered. So flow routing is the procedure to determine flow hydrograph at any given point of the watershed. It accounts the flow hydrograph as flow passes the downstream, and it helps in the accounting the storage and attenuation of the flow peaks. Similarly, there are different type of flow routing option available in the model. So hence the model with desirable flow routing should be selected to meet the objective of the model. So there are, basically you can classify the flow routing process into kinematic, dynamic, or masking wave flow routing, and the requirement or the peculiarity of your watershed or the level of data you have, understanding you have, you should go for the flow routing selection as well. So the model which have your desirable flow routing option, for my one of the study, it was in the hilly areas, and for me I have done a literature review, and then I have known that the dynamic wave method for flow routing would be good for the modeling the watershed with where the slope of the terrain is quite steep. So what are the options available in the hydrological model that should be also be considered in while selecting the hydrological hydrological modeling processes in the hydrological model selection. Similarly, the resource requirement. I have already told that the hydrological model needs precipitation data, stream flow data, physical data as input resources. So final resolution is assumed to be a better give better result, but there are two constraints associated with the final resolution data. That is the complexity on the model and the scarcity of the data with the final resolution. So hence, depending on the objective of the modeling study, level of accuracy needed, and the output adequate demanding model should be selected. So as I have already told, that the resource requirement would be the important criteria while selecting the hydrological model. So resources, what the resources you require for while developing the hydrological model, I have classified into two. That is hydrometeorological data and physical data. So in the hydrometeorological data, especially if you say the precipitation or meteorological data, that can be classified into a gridded, stationed, or average. So in some hydrological model, you need a gridded precipitation data, or in some hydrological model you may need the stationed data, or in some hydrological model, if you have just an average the Thiessen polygon data or average data, and that would be the surface. So what is the data requirement for the model, and what is your availability in the watershed that should have a compromise meet, and similarly the physical data as well. So another thing would be the document support. The hydrological model are based on theory and assumption, and most of the model conceptualizes the process of overland flow, infiltration, soft surface flow, and their interrelation in very unique and different way. Most of the models, the conceptualization of the processes varies from model to model. For the model setup, pre-processing and post-processing of output need a documented guidance. So hydrological model basically develops two set of manuals, namely a technical manual and user manual. So technical manual give the underlying processes, how it is being calculated, whereas the user manual usually give how the model should be dealt with, how it operates, or the processes about how it is going to be used, it should be used. So generally hydrological model developers provide two set of manuals. So the hydrological model, another thing is the model which has been enough cited in literature and have the technical and user manual available are generally preferred. If you have enough information or enough idea of the underlying processes, then it's good. But in the absence of technical manual and user manual, those hydrological model would be just converted into the black box model. Finally, another important criteria to be considered would be user interface. So user interface is like a conduit between user and the system of the model. And hydrological model nowadays mainly are computer based. They also call it the mathematical model, but it is completely based on computer. And user interface is an important part of the model to be considered. So graphical user interface, or it is also known as GUI, are most common in these days, that helps to prepare data, calibrate model, run a simulation, help to visualize the static and dynamic graphs of the output. So GUI is a necessary component in hydrological model for ease and efficiency of the model users. So some hydrological model have advanced GUI, whereas where model can manage, visualize every component process of the model and display output in the graphical and tabular format. So GUI of some model are not advanced enough to manage and visualize the output. And in other hand, some model have they don't have their own the platform, and they are written in Fortran or MATLAB, and they don't have their own platform, and they should go for the platform, the third-party platform, just like Grass or ArcGIS or QGIS platform. They should be used. So there are, as I have told, that there are numerous models. So nowadays the computer models do have their own graphical user interface, and they are quite advancing. But there are also the hydrological model which do not have their own graphical user interface, and some hydrological model just perform in the spreadsheet or in the Excel with the mathematical code. So what is your requirement, and what is your preferences on the ease of use that would be also be considered in the user interface criteria of model selection. The sixth criteria for model selection is model calibration. So automatic calibration, you can classify model optimization into the manual optimization and automatic optimization. So the automatic calibration, if we talk about it, is mainly focuses on the selection of objective measure of variation between model simulated output and observed data, and the selection of optimization algorithm to search the parameter value with minimize that variation. So automatic calibration is the method which look for the observed data and the simulated data, and try to minimize the variation of those with the selection of the automatic optimization algorithm, the process of automatic optimization algorithm. So most of the hydrological model do have automatic optimization, but not only automatic, they go for global and multi-objective optimization function. where some models have third-party software for optimization, and some models do not have automatic optimization model. So what is the preference of the modeler? If they would like to go for a global optimization process, or have need automatic optimization method in the hydrological model, the hydrological processes, then the modelers should go for the automatic calibration models, automatic models which have automatic optimization options. So yeah, so it is like I have been talking for a long, so I'll just like to throw a question to the participant. If they know about global optimization and the local optimization, the difference between global optimization and the local optimization. Anyone would like to answer this question? You can just write it here. Yes, I have just given a question. You can just write the difference between global optimization and the local optimization, and I'll move forward to the another criteria for model selection, that is the availability of model. Just I have told in the beginning of my presentation, if there are different type of model, some of the models are available in public domain, while some are exclusive and some are for the commercial purposes. So on the basis of the availability, hydrological model can be classified into the public domain or freely available. Exclusive models or commercial model. Public domain models are available for free of charge. Sources are available with easy access, whereas exclusive models are not freely available, but they do not cost as well for model acquisition. The exclusive model needs authorization or permission from the developer before use. And similarly, there are commercial models, and they are developed for commercial uses and need to be purchased. So depending on the fund available and depending on the purpose of the study, the model should be selected based on the availability of model as well. So these were the seven criteria for model selection, and on these criteria there are multiple factors as well. So these were my the criteria and factor and the preferences level for my study. And it was rural watershed in the hilly areas of Sri Lanka, where I conducted this study. So I was not having fund to collect the or purchase the hydrological model. So depending upon my requirement, I have classified models and sort out my criteria, then factors, and given the preferences from high to low. Likewise, any modeler can give the preferences and sort out their criteria and multiple factors and give their preferences and choose a suitable hydrological model. So now I'm end of the first segment of my presentation, and that was how hydrological model should be selected based on the criteria evaluation. You can first select the criteria and their factors, and give the preferences label, assign their values, and or assign the weighted values, and get a final result. So I'm citing here two literature. And the one is in the natural resource modeling, and the paper is a methodological framework for hydrological model selection process in water resources management project. This research also give a framework, a methodological framework, how hydrological models should be selected for a modeling study. Similarly, the another literature is the paper was written by me and published in Journal of Water Engineering and Management, and it is on this the process of selection of hydrological model and objective function for water resources management in the rural areas using criteria based evaluation. Yeah. Now we'll head towards the another segment of the presentation, that would be in the objective function. This is also an important factor to be considered in hydrological modeling. So yes, Anyone would like to answer what is objective function? And what is the use of objective function? You can just write it. Okay. So yes. So is my slide visible?
Pratik,
Yes, yes.
so what is that local optima and the global optima? You please explain as a layman. Local optima and global optima. If you have any idea.
Okay. So the local optima is you just look for a single parameter, and try to optimize that parameter and look for the objective function of the model. And once you reach into the optimum level, then you just leave and go for another parameter for.
So means local variable or the parameter that may be the infiltration rate.
Yeah.
And the objective function may be R square or NSE.
Yeah.
Okay, so infiltration rate will be optimized to get the appropriate value of NSE.
Yeah, NSE.
The objective function.
Yeah, one at a time, and then
one at a time.
Yeah, then you just move to another, and at that time, the NSE may go up or low, and the optimization you have done in the infiltration would not be done again. But in the global optimization, you look for all the parameter at one at a time, and look for a compromised optimization, and you get a set of compromised parameters, and that will be compensating one to another.
Yes.
Yeah.
I got it. Yeah. Since we are discussing, let me read a question from Divya. She is asking why urban spatial scale model is less preferred. Urban spatial scale model.
Okay. Yeah, so it's not less preferred or highly preferred. If you want a model to be if you have a research study or case study to be conducted in the urban watershed, then you'll definitely go for the model like stormwater management model, or you can say SWMM, and that is specially designed for urban watershed. So depending upon the purpose of your study, you go for the model selection. It's not less preferred or highly preferred. It's always about the rational selection or rational decision on the selection of the model.
Divya, any example of urban spatial scale model? I don't know any model which is named by this term. Yes, Divya.
Sir, actually, in the criteria sir has listed, there he listed like the urban spatial model is less preferred.
Okay.
That's why I asked. Based on that criteria,
that I didn't see. Okay, yeah. Fine.
Yeah.
Okay, sir. Now you please go ahead.
Yeah. Okay. Another aspect of the hydrological model that should be in the hydrological modeling should be considered is the objective function. So, what is objective function? Hydrological simulations are calibrated by comparing observed data set with data generated model, and the objective function is the function of difference between computed and the observed data set during the calibration of model. So the choice of objective function is also another subjective decision, and that influences the value of parameters and the performance of models. So the selection of objective function should also be very rational, and that would really influence the model parameters and performance of the model. So there is a definite link between mathematical formulation and objective function and the type of engineering application which the model is used. So objective functions are different. There are a lot of objective functions. There are a lot of efficiency criteria available, but all of them has some mathematical function, and that mathematical function is associated with with some engineering application. So you have to find the link between the mathematical formulation and of the objective function and the type of engineering application that could be used. So the most common indicators or the goodness of fit, also they call, or the objective function in the literature to evaluate flow hydrograph are Nash shortcliffe, or mean ratio of absolute error, root mean square error, relative error, something like R square, or coefficient, Pearson coefficient, correlation coefficient. So there are the 4 or 5 I have listed here, but there are multiple. There are multiple objective function available in literature. So nowadays in the hydrological model, you go for multi objective optimization process. But my school of thought, my the research, the experience, I say that you should rather go for a single optimization model, a single optimization, a single objective function model, because for that you should have a clear idea of what engineering application, or what the purpose of your study. If you are trying to perform for a flood management or flood control engineering application, and you are supposed to do a hydrological model, so you just sort out the objective function that perform better in flood hydrographs or for flood management studies. So likewise, you can exclude other objective functions or other goodness of fit. So it's not necessary you have to have a lot of objective functions and go for a multi-objective optimization. If your purpose of the study is clear and what you are aiming for, then you can go just for a 1 or 2 objective function to have a better calibration, a better optimization of the model. So yeah, I've just told a few examples of objective function. I'll not go very deep into all these objective function, their mathematical formulation, but I'll briefly go in a few of these objective function, like Nash shortcliffes and MRA. So Nash shortcliff is one of the objective function that is being popularly used for optimizing the model parameters. So it is a normalized statistics that determines relative magnitude of residual variance compared to the measured variance. So variance that observed discharge minus calculated discharge squared is the variance. So this is just a mathematical formulation of this Nash shortcliffe efficiency. So, but you have to if you go deep into Nash shortcliffe, it has a largest drawback is that the difference between observed and simulated values are squared values. As a result, larger values in the time series, if you have a continuous data of 8 years, the larger value are overestimated, where lower values get neglected. So if the model is not performing in the lower data, or if model is not performing even in the the low flows or the intermediate flow region of the hydrograph, the Nash shortcliffe can give a better result, and that would be a complete disguise that the result is showing a good, it is closer to 1, it's like 80% efficiency or 90% efficiency, but it is not giving a proper matching in low flows or intermediate flows. So that is the largest drawback of Nash shortcliffe efficiency. So best objective function but it is the best objective function for peak flow matching. So having told that, I would say that Nash shortcliffe is a good efficiency criteria, goodness of fit for flood hydrograph or flood modeling purposes. If you are trying to model for something like water resources or drought management case study, then you should rather go for other hydrological other efficiency criteria than these Nash shortcliffe efficiency. So you have to properly go deep into the objective function, the mathematical formulation, do a deep literature review before selecting the objective function of the for your study. The second objective function I will be mentioning here is mean ratio of absolute error. So the mean ratio, in the mean ratio of absolute error, what happens is the difference between observed and calculated discharge. It is the ratio of the observed of calculated discharge with respect to the observed one. So it's a mean ratio is the difference between calculated and observed flow with respect to particular observation. So it gives error with respect to each and every data set, each and every point in the data set. So but the thing is, the best fit between observed and calculated value would be 0 value for MRA. So the thing is, in the MRA, if the observed value is 0, then it would be invalid because it would be divided by the 0. So the major drawback in the mean ratio of absolute error is that if there is no flow condition in the hydrograph, then the you should not select this mean ratio of absolute error. So if you select mean ratio of absolute error as an objective function, and if there are no flow condition, then this objective function would not give a better result, or it will go completely void. So I have listed out the merits and demerits of few objective function and the purpose as well of those objective function. Is my slide visible right now?
Yes. You are clearly audible and slides are visible.
Yeah.
Please go ahead.
Yeah. So there are I have listed 4 objective functions. So those objective functions are like Nash-Cliffs, root mean square error, or ratio of absolute error to mean, and mean ratio of absolute error. So there are a lot of other objective function as well, but you have to go deep inside the literature and the mathematical formulation before selecting them for your study. So for Nash-Cliff, it's sensitive to flow magnitude and highly used for flood modeling. So that is the advantage. It is highly used for flood modeling, and the demerit is the larger value in the time series would be overestimated, whereas lower value would be neglected. So it is the application. It has been mainly used for flood modeling. Similarly, root mean square error. The merit is the measure uncertainty in the prediction, and the demerit is that cannot tell how accurate the model are. It emphasizes greater errors than the lower ones. So it emphasizes on the more error. It's the indicator of error. So it emphasizes on the greater error, and the smaller errors in the model would be the neglected. So it is mainly chosen for the drought modeling. So similarly, the model, this objective function is the mean ratio of absolute error, MRA, which gives a better representation when contrasting data are present in the objective data set. But the major demerit is it cannot be used if there are 0 in the observed values, because they would be divided by the 0. So water resource modeling, this model is heavily used for water resources modeling, namely like for the utility purpose. If you would like to build a irrigation reservoir or something like that, or for a drinking water supply condition where the intermediate flow regions are more important. In these cases, the mean ratio of absolute error are selected. So based on the purpose of the study, based on the engineering application of the hydrological model, the objective function should be selected. As its name suggests, the objective should be clear. So other indicator, furthermore, with the Pearson coefficient and root mean square error, these I have listed all these model mathematical function and their purpose, and you can just go through it later in this slide. So I'll be sharing 2 other references for selection of the hydrological model objective function in hydrological modeling, and that is the procedure for selecting objective function for hydrological simulation model, and another is comparison of different efficiency criteria for hydrological model assessment. So this objective function is sometimes called objective function, efficiency criteria, goodness of fit, or whatever. But the selection of these objective function or efficiency criteria or goodness of fit should be rational and based on the engineering application you are, or the purpose of the study you are supposed to carry out in your watershed. Now the fifth domain I'm going to touch in this lecture is the flow duration curve. Yeah. So how many of you are familiar to flow duration curve? Yes. Yes. Okay. So flow duration curve. So it has flow duration curve has a significance in hydrological modeling because you can identify the flow threshold of the flow hydrograph, and you can tally with the simulated result of the hydrological model and see which regime or which area of the flow hydrograph is, or which area of the flow is giving a perfect result in the hydrological modeling. If you want flood model, and if the model is giving better result in the intermediate flow regime or the low flow region, then this model cannot be good for flood hydrograph. Or if you want a model to be used in the drought modeling, or if you want model to be used for some water resource development process rather than flood modeling, then you would rather go for intermediate flow or the low flow region, and your requirement for a peak flow matching may not be as important as the intermediate and low flow region. So flood hydrograph, flow duration curve matching should also be considered, and should also be importantly looked while hydrological modeling is performed. Your hydrograph matching, and while you are matching your hydrograph or you are inspecting your flow hydrograph, comparing your observed flow hydrograph and simulated flow hydrograph, you may not recognize if your intermediate flows are perfectly matching or not, or if your objective function sometimes may not give clear picture if your intermediate or low flows or high flows are matching, what is the condition of the flow regimes. But if you try to compare the flow hydrograph between your the observed and the simulated one, then you will get a direct picture how your flow regimes are matching or not, in which regime, either it is high flow or intermediate flow, in which regime the model is performing better, or if your purposes of the modeling is being fulfilled or not, that can be checked. So what is flow duration curve? Flow duration curve represents the relationship between magnitude and the frequency of daily, weekly, monthly stream flow for a particular river basin, providing an estimate of the percentage of time a given stream flow was equaled or exceeded over the historical period. So the most appropriate tool, the flow hydrograph, the flow duration curve is also is the most important appropriate tool for determination of stream flow threshold. So if you have a hydrograph, if you have a data, hydrological data, and if you would like to classify your hydrograph or hydrological data into three domain, high flow, medium flow, or low flow, then how would you do it? So for this, giving the threshold for flow regime, the flow duration curve is a very appropriate tool. So there are application related water power engineering, water supply, locating industrial plants, pollution studies, climate change impacts, human activities. So the flow duration curve has a lot of activities, and especially nowadays the flow duration curve are being used and preferred in the environmental flow requirements. In the mountainous areas, they, especially in Nepal or the northeast of India or Bhutan, there are being a lot of hydropower development, and the environmental flow requirement guidelines are required. So for those conditions, the flow duration curves give would serve as a tool for determining stream flow threshold. You can determine that the 10% threshold of this stream flow is low flow, so you should at least preserve the low flow condition or the intermediate flow condition. So yes. So what is how much percentage of the flow is high flow? How much percentage of the flow is the low flow? That is still not the clear. So the US EPA says that the flow that exceed 5th percentile and is high flow, and the flow that exceed 95th percentile is low flow. And a researcher, the Russian researcher, did a study of the Nepalese River Basin and the other South Asian river basin, and they said that like 70 to 99% of time of accidents would be considered as a low flow condition. Similarly, United States Geographical Survey have conducted a research and said that 5th and 10% percentile accidents as a high flow and 95% accidents as a low flow. But they have also said that it can vary as per the watershed condition. And US EPA further divided flow condition into 5 flow region. Number 1 condition is high flow, that would be 0 to 10% of time of accidents, and that is called high flow. And another condition is the moist condition, that would be 10 to 40% of the percent of time of accidents. Similarly, mid-range flow, that would be 40 to 60%, and dry condition 60 to 90, and the low flow condition 90 to 100. So there are a lot of standardization or guideline that says that what the high flow, low flow, or intermediate flow should be, but it may vary from watershed to watershed. The high flow of your watershed or the high flow of other watershed may vary. So it should also be rationally selected. What is the high flow condition of your watershed or your hydrograph? In my study, I'll give an example of my modeling study I've carried out, and here I'm showing this is a watershed in Sri Lanka called Ellagawa watershed, and the hydrograph of 2006 and 7. This is the hydrograph of 2006 and 7, and I did a modeling study there using stormwater management model, and 2006 and 7. For the year 2006 and 7, you can clearly see the good matching of the hydrograph in the all regions. But here, if you see the flow duration curve, the high flow region, where in my study I have considered the flow region above 10% percentage time of accidents is considered high, and the flow regions 80% time of accidents are low, and between is the intermediate or the medium flow condition. So here you can see the high flow are thoroughly being underestimated by the model, whereas low flows are being overestimated, and the intermediate flows are being fairly estimated by the model. So I could conclude that my modeling work did not work good for flood management or flood modeling process. Rather, it would be good for some water resources development project or water resources management project. So it did not work good for flood management or flood control project. So depending upon your engineering application or the purpose of the study, your hydrological model and this flow duration curve would serve a tool for how and which regime of the hydrograph is being modeled fairly or roughly or badly. So I'd like to share another reference by Professor Sohan Wijayasekara. He was my supervisor in Sri Lanka, and he had authored a paper called a streamflow threshold determination method for hydrological model calibration and verification in Engineers Journal of Institute of Engineers Sri Lanka, where he have clearly given the process how you can classify the threshold or give estimate the threshold of the hydrograph to high, medium, and low flows. Or you can just inspect at your hydrograph and the flow duration curve and give a high and medium and low. So generally it is considered that the 0 to 10% is considered as the high flow, 10 to 80% is as the medium or intermediate flow, and 80 to 100% is percentage time of accidents is called low flow. So this is the reference, and I would like to if the participants are not familiar in flow duration curve, I can share you the spreadsheet calculation after this lecture. I'll just go. Yes. So I'm just giving a spreadsheet calculation way of calculating it and showing it to you all, and I'll also share you the spreadsheet, and you can try it on your own after looking at this flow duration calculation. So this is yes, the spreadsheet is visible.
No, it's not.
Is it visible now?
It's not visible to me.
Okay, let's stop sharing. I think it's visible now, right?
Yeah, not.
So what I have done is I have the data from 2006 to 2010. This was the 4-year data for calibration of my model, and this is the observed streamflow data. The observed water yield, especially in specific in mm per day. So this was the observed water yield of my watershed, and this is the simulated water yield of my watershed. So how would I draw a flow duration curve of this watershed, this hydrograph, and compare with my simulated streamflow data, simulated water yield data? So what I did was I just arranged this my observed streamflow data, just selected all these and arranged it in a ascending to descending form, that is largest to smallest, and the corresponding date and the corresponding streamflow is also simulated streamflow is also changed. So yes, the highest streamflow highest observed streamflow or highest observed water was 103 mm per day, whereas the corresponding high stream flow or the water yield is only 37. So you can see my model was very badly estimating the higher flow region, whereas if you go in the lower domain, in the intermediate flow, it is fairly estimating here. So you can just looking at the values, you can just get the idea that the high flow regions are not being properly estimated by the model. Now what I did was gave the order of magnitude from 1 to there are 1461 data. So I gave the order 1 to 1461. Now you can calculate the probability of the accident. The probability, the formula is this flow which is 103 occurred only one time. So the probability of occurring it in the flow hydrograph or in the data is like almost 0, whereas this 0.65 mm per day occurred almost, the value above this are almost all. So the probability of occurring this flow is almost 100%. So this way I calculated the probability of accident. The formula is the order of magnitude divided by the number of the data, and if it is or you can just add 1 and make it even. If it is even, just leave it. So number of data in the time series, my number of data in my time series was 1461 for 4 years, and it is odd, so I added 1, and this is the probability of accident. So I plotted it, the order of this is observed and the corresponding stream flow. So you can see that if I magnify it, if I magnify it, and this is in the logarithmic scale, to see the data visualize the data in the magnified version. So if I magnify it, I can see that the higher flow regions are not being properly estimated, and the underestimated rather, and the lower flow regions are being overestimated, and the middle range is being fairly estimated. So these cannot be shown through your objective function or your hydrograph comparison. So for you to see how which regime of the watershed is being properly modeled, or if to ensure that if your high flow regions are being properly modeled or not, you have to go to this flow duration curve and visualize and inspect if your model is giving fair result in all the flow regions or desired flow regions or not. With this, I have come to the end of my presentation, and if you have any question, I'll be happy to answer. Yes. So I have come to the end of my presentation. So if the participants have any questions, so I'll be answering them.
Any question, please? Especially Mr. Pratik, we do not use the flow duration curve in our hydrological that modeling studies, but it's quite good that's a better way to see how the high flows and low flows are matching. So this is quite interesting.
Yeah.
Normally FDC we are using to estimate the environmental flows in the river.
Yeah.
We have been using this. Any question from the participants, or still they are there? Yeah, Suman De Burban is asking, can we use FDC in observed data only?
Yeah,
Okay.
you can calculate FDC just for observed data, but in my presentation I said that you can see if your model is giving clear, that if your model is estimating the flow regimes, or to verify the model result in all the flow regime, your purpose that this is an additional purpose the FDC can serve. So just before the Professor Ajay said that he used to use FDC just for the observed data for environmental flow consideration, or for separating the flow threshold in the watershed in the flow hydrograph. So yes, you can only calculate flow duration curve for observed data. That is what being done initially, but this is another area of the engineering or in hydrology I'm describing in my presentation.
It is always better to use the FDC for the predicted values also, because ultimately this is going to give you the accidence of probability, which is quite informative. It is good to use with predicted values also. You can use both. So Suman is quite attentive during the whole program.
Yeah.
That's good. That's Suman, what you are doing? Are you a student or you are in a job?
Sir,
So,
student, sir.
student, yeah, you look
Sir,
like a boy.
geography. Sir, I have geography background and my research area mainly fluvial geomorphology.
Fluvial geomorphology. That's quite
interesting.
this program is quite good for you. So you are master student or you are doing PhD?
Sir, PhD, sir. Masters I have sir, completed 2015.
Okay. PhD from which university you are doing?
Sir, the University of Burdwan.
Burdwan, West Bengal.
Yes, sir.
Good. Very nice.
Sir,
Yeah.
one question another. You were mentioned the calculate the threshold, determine the stream flow threshold. So,
Yeah.
like others parameter, we apply different statistical tools to identify this threshold. In that case, it is only probability.
I didn't get your question. Can you repeat it, please?
Sir, in our geographical research, for the other parameter, we are calculate the threshold value. But for that case, fluvial flow duration curve, how to set calculate this threshold? Just with percentile from percentile value, like your 10%, 90%. That
Yeah.
case.
Yeah. So at the end of the presentation, I have given a literature, and I'll also be sharing the spreadsheet how to calculate the flow threshold, high, medium, and low. But generally it is the researcher, they go to the literature by the agencies like US EPA or USGS. They have the general trend of taking 10% as a low flow and 10% as a high flow, 80% as a low. So that is the being trend. But there is a paper, there is a process that says that how detailed you can go through the spreadsheet and go calculate each and everything, and rationally select high flow, low flow, and intermediate flow, and that would be specific just for your watershed. There is a process. Yes, you have to go through that paper.
Yes, I would like to add, a threshold is going to be decided by the project, your overall mandate for which you are working. If you are planning some irrigation system design, that it may go up to the 90% or like that. Means that a particular flow will have the probability of 90%. So with this, you can plan the irrigation system. So it depends upon that overall objective of the program also. Is it true, Mr. Pratik?
Yeah. That's
Yeah.
fine.
So I think with this, let us close this session. And very nice lecture was delivered by Mr. Pratik. Very interesting, especially I found that statistical measures and its interpretation, that the flow duration curve was quite interesting for me also. Very informative session, sir. And we thank that you agreed to deliver the lecture in the FDP that organized by Central University and then AICTE. We are very honored. And I would like, I just requested that one of the participants to extend thanks on behalf of all the participants. I think Rajneesh Kumar Burma has agreed. I would request him to say a few words. Rajneesh, you can that put on the camera and please say something.
Yes, sir.
Yes, Rajneesh.
Yes, sir. Good afternoon, sir.
Good afternoon. Yes.
Good afternoon.
Well, sir, I would like to thank Mr. Pratik Singh Thakuri on behalf of all the participants for his very informative lecture. The whole lecture was quite impressive and contained valuable information, and it will help in our research work. Thank you, sir.
Thank you, Rajneesh.
So he is one of the participants, and thank you, Rajneesh.
And you are from police force or defense?
No, sir. Actually, that was my NCC photo. I have done NCC.
Oh, NCC, National Cadet Corps. Okay.
Yes, sir.
Okay.
Hello, sir.
Yeah.
Savita NM is also writing. Thank you, sir. Praveen Kumar has also extended. Yes.
Yeah.
Thanks.
Thank you, everyone, and thank you.
Yeah. Okay, Mr. Pratik.
Yeah.
With this, we are going to close this session, and next session will be resumed at 3 o'clock. Yes, Oman. Yes. Last one.
Sir, I want question, sir. For getting different discharge and sediment data of Nepal, how to get as an Indian research scholar?
Okay, you would like discharge and sediment. You know, the discharge data, you can go to the website of Department of Hydrology and Meteorology, and you can just put a query, and they'll give you the available discharge and precipitation data information, the availability just, and then you have to write the data time series, which data span you like. Then they'll estimate the budget of the data you need to pay for it. Then if after paying, you'll be able to get it. But yeah, it's available in the website of Department of Hydrology and Meteorology. It's called DHM. Yeah. And the sediment data that is not being collected by any one agency. It is being collected by the projects, hydropower projects or other hydropower dam projects. So it's scattered. It really needs work to be done. Yeah.
Or else the most easiest way that you can include Mr. Pratik as your co-supervisor.
Yeah.
Suman, that you can explore whether he can be added as a co-guide in your dissertation program or not. So if he does, then he will make you available all the data.
Yeah, sure. So yeah, if any participant have any further queries, or they would like any suggestion, or they have any problem, or they would like my suggestion, then you can email me, and I have provided my email address in my presentation. I'll be sharing my presentation slide to Professor Ajay, and he'll be circulating, I think, the document. And you can always email me, and I'll be I'll try to help as possible. Yeah.
Okay, sir. Thank you very much. So with this, we will close the session here, and we will again will be resumed at 3 o'clock for a hands-on session. That will be delivered by DHI. Okay, Pratik.
Thank you.
We'll see you later. Thank you.